Bismillahirrahmanirrahim. Uh, my dear students, today's lecture topic is tissue repair. The term repair, when used in the context of healing, damaged tissue is defined as the restoration of the tissues, architecture, and function after the injury. As far as regeneration is concerned, regeneration refers to the type of healing in which new growth completely restores the portions of damaged tissue to the normal life state. The two primary types of tissue repair are there: regeneration and the fibrosis. In regeneration, the injured tissue is replaced through cell division and the same type of cells, which are known as parenchyma. In the fibrosis, the fibroblasts are produced and they synthesize the collagens and other material to form the scar tissue. Whenever there is production of fibroblast, the fibrosis takes place and the scar formations will also form there. The damage is extensive, both the processes will take place to create a growing connective tissue, which is known as regeneration tissue, which forms the stroma or the frameworks for the new cells to move in and protect against the bacteria. The combination of both proliferation, fibroblast, and loose connective tissue and the new formations of the blood vessels, which is known as angiogenesis, provide oxygen, nutrients, and cells required to repair the damage, and scattered chronic inflammatory cells form the type of tissues which is unique to healing wound and is called a granule tissue. The different cells found in the granule tissue are the capillary endothelial cells, fibroblasts, and the biofibroblasts. The formation of the granulation tissue is a part of process of organization. An organization is a process by which the specialized tissues that have suffered damage undergo the fibrous repair to form the scar. Granulation tissues fill in the gap that is initially left by the damage to the tissues. And there is the formation of new blood vessels, which is known as angiogenesis. And the new blood capillaries provide oxygen, nutrients, and cells required to repair the damage. You see, this is the normal portion of the skin. Epithelial cells are here with the nucleus. You can see the epithelial cells have the nucleus present here, their normal architectures, and there is no injury in this section of the specimens. And these are the blood vessels, and the blood cells are passing through these blood vessels, blood and the blood vessels. So in mild superficial injury here, if there is a mild superficial injury, means when the epithelial cells are damaged, but they are not completely damaged. You can see their nucleus also, and you can see the disrupted shape of this portion of this skin. So when this type of injury occur, mild superficial injury occur, there is regenerations of the epithelial cells take place completely, and the normal original architecture will be formed as it was before the injury. On the other hand, when there is severe injury, this is a severe injury, you can see all the epithelial cells, they are completely destroyed here. You can't see the epithelial cells in this portion, and hence there is a deep injury. And the injury and the wound has gone below the epithelial cells, entered into the vessel nearly. So in this type of severe injury, there is a scar formations. This will occur here. The healing is occurring here. The tissue repairs are occurring here. Fibroblasts are produced in these sections, and ultimately there is the formation of the scars, which is permanent. In this here, there is no scar. Epithelial cells have been grown again in normal shape, and it is acting as the same thing as it was before injury. But on this side, in the scar formation, it will remain like this, and the actual genuine epithelial cells before injury, but they cannot come again. So scar formation is a permanent repair of the tissues. The processes in fibrous repair from initial injury to the formation of scar. Processes involved in fibrous repair is the phagocytosis of the necrotic tissue, the angiogenesis, which is new blood vessels growth, and granulation tissues become less muscular to form mature scar. The scar shrinks the fibril within the myofibroblast. As I already told you about the regeneration. What is regeneration? Repair of the connective tissue. Tissue deposition consists of four sequential processes. One is the angiogenesis, which is the new formation of the blood vessels, migration, proliferation of the fibroblast, deposition of the ECM, extracellular matrix, ECM, extracellular matrix, deposition of the ECM, which ultimately causes the scar formation. Finally, there is maturation and reorganization of the fibrous tissue remodeling. Healing by repair, scar formation, and fibrosis. Healing by scar occurs when repair cannot be accomplished by the generation alone, characterized by the replacements of the injured cells with the connective tissue, leading to the formation of the scar. Healing by scar is a rule if the tissue injury is severe or chronic damage to parenchymal cells and epithelial as well as to the connective tissue framework, or if non-dividing cells are injured. Steps in the scar formation are inflammation, angiogenesis, migration and proliferation of the fibroblast, scar formations, and connective tissue remodeling. These are the 5 steps in the formation of the scar formations. In case of inflammation, the number 1 step, and this step is comprised of typical acute and chronic inflammatory response. Breakdown products of complement activation, chemokines released from the activated platelets and other mediators produced at the site of injury and recruit neutrophils and then the monocytes during the next 6 to 48 hours. There is recruitment of inflammatory cells, which are WBCs, especially the neutrophils, at the site of the injury. These inflammatory cells eliminates the offending agents such as microbes that may have been rough that may have entered through the wound and clear the tablets. Macrophages clear the microbe and necrotic tissue and promote inflammation, and then the macrophages, they produce growth factors that stimulates the proliferation of many cells type in the next stage of repair. Finally, all the injurious agents and the necrotic cells, they are cleared, then the inflammation resolves. The second step in the formation of fibrosis is the angiogenesis, that is the new development of the new vessels. Blood vessels formation during the embryonic development called vasculogenesis. In adult, it is called as angiogenesis or neovasculogenesis. In adult, mechanism of angiogenesis is branching and extensions of adjacent pre-existing vessels and possibly the recruitment of endothelial progenitor cells from the bone marrow. New blood vessels supply nutrients and oxygen needed to support the repair process. Angiogenesis in physiological process, wound healing, regeneration, vascularization of the ischemic tissues, menstrual cycles, pathologic process, tumor development and metastasis, diabetic neuropathy and chronic inflammations. The third step is the migration and proliferation of the fibroblast, also called the formations of the granulation tissue. Migration of the fibroblast and the depositions of the loose connective tissues together with the vessels and the leukocytes forms the granulation tissue. The term granulation tissue derived from its pink, soft, granular gross appearances. In the histological appearances, there is proliferation of fibroblasts, angiogenesis, loose connective tissues matrix admixed with the inflammatory cells, mainly the macrophages. The fourth step is the scar formation. Ultimately, the granulation tissues evolve into the scar compositions. The compositions are largely inactive cylinder-shaped fibroblasts, dense collagens, fragments of the elastic tissue and other ECM, extracellular matrix components. Proliferation of fibroblasts and new vessels is decreased. Fibroblast assumes a more synthetic phenotype. There is increase in the collagen products and decrease in the collagen degradation. Collagen synthesis while the fibroblast begins early wound healing 3 to 5 days. The following are the features of maturing scar. There is progressive muscular regression, appear largely avascular scar. Some of the fibroblasts also acquired features of smooth muscle cell. Contain actin filaments and are called myoblasts. Fibroblasts responsible for contraction of the scar over time. The finally one is the remodeling. The balance between the extracellular matrix synthesis and degradation results in remodeling of the connective tissue framework. Degradation of collagens and other ECM proteins is achieved by matrix metalloproteinase lines, which is also known as MMPs. The MMPs are produced by the fibroblasts, macrophages, neutrophils, synovial fluids, and some epithelial cells. The secretion is induced by the growth factors, which are PDGF, platelet-derived growth factors, and FGF, cytokines like interleukin-1, tumor necrotic factors, and phagocytosis in the macrophages. It is inhibited by the tumor growth factors beta and steroids. Local synthesis, local and systemic factors that influences wound healing. The systemic factors are nutrition, metabolic status, circulatory status, and the hormones like glucocorticoids. In case of nutrition, the deficiency of C will inhibit the collagen synthesis. While in case of metabolic status, diabetic mellitus causes microangiopathy. Regulatory status, inadequate blood supply makes impaired healing. Hormones, glucocorticoids, anti-inflammations inhibit collagen synthesis. The local factors are infections, mechanical factors, foreign bodies, and size, location, and type of wound. In case of infection, the single most important cause of delay in healing because it results in persistent tissue injury and inflammation. The mechanical factors may be such as early motions of wound can delay healing by compressing blood vessels and separating the edges of the wound. Foreign bodies, size, location, and type of wound. Wounds in richly vascular areas such as face healed faster than those in poorly vascular one such as the foot. Cutaneous wound healing is divided into 3 phases: inflammation, proliferation, and maturation. Tissue proliferation activity. The tissue of the body are divided into 3 groups on the basis of the proliferative capacity of their cells. One is the continuously dividing, which is known as the bile tissues, the stable tissue, which is quiescent tissues, and the third one is non-dividing. This non-dividing is also known as permanent tissues. So there are 3 steps: continuous dividing, the bile tissues, quiescent or the stable tissues, non-dividing, the permanent tissues. Because the continuous dividing tissues, that is the labile tissues, cells proliferated throughout the life, replacing those that are destroyed by the maturation of the tissue stem cells and by proliferation of the mature cells. These tissues include surface epithelial of the skin, oral cavity, vagina, cervix, the colon epithelium of the GIT tract and the uterus, the transition epithelium of the urinary tract, and the cells of bone marrow and hemopoietic tissues. In most of these tissues, mature cells are derived from the adult stem cells. The labile tissue, which is also known as continuously dividing tissues, cells of these tissues are continuously being lost and replaced by maturation from the tissue stem cells and by proliferation of mature cells. Labile cells include hemopoietic cells, bone marrow, majority of the surface epithelia, such as the stratified squamous epithelium of the skin, oral cavity, vagina, and cervix. The cuboidal epithelium of the duct, draining exocrine organs like salivary glands, pancreas, and biliary tract. The columnar epithelium of the GIT, uterus, and the fallopian tubes, and the transition epithelium of the urinary tract. These tissues can readily regenerate after injury as long as the pool of the stem cells are preserved. Second one is the stable tissue or the quiescent tissue. The cells of tissues are quiescent and they constitute the parenchyma of most solid tissues such as liver, kidney, and pancreas. The minimal proliferation activity in the normal states, but capable of dividing in response of injury. They also include endothelial cells, fibroblasts, and smooth muscle cells, which leads to the proliferation of these cells in particularly important in food dealing. The non-dividing or the permanent cells, they are cells are considered to be terminally differentiated and non-proliferative in postnatal life. The majority of the neurons, skeletal, and cardiac muscles cells belong to this category. Injury to the brain, heart, or are irreversible and result in scar. Neurons and cardiac myocytes cannot regenerate with permanent tissue repair is typically dominated by the scar formations. As I already told you about the permanent tissue, the cells of these tissues are considered to be terminally differentiated and non-proliferative in postnatal life. The majority of the neurons and the cardiac muscle cells belong to this group. Thus, injury to the brain or heart is irreversible and results in scar because the neurons and the cardiac myocytes cannot regenerate. According to the potential of cell renewal, three types of cells are present. The labile cell, which is continuously dividing cells, the stable cells with a low level of replication, and the permanent cells which never divides. Now the number one, the labile cells, they are regenerated regularly. The surface epithelial cells, the surface epithelium of the GIT in the skin, where the human finds and these labile cells. The stable cells, with a low level of replication, normally slowly regenerate, divide when necessary. The example, hepatocytes, liver cells, histocytes or hepatocytes, renal tubular epitheliums, pancreatic epithelium. The permanent cells, they never divide, no effective regeneration. Example, neural cells of the central nervous system and the cardiac muscles. Now the growth factors. The growth factors are soluble signaling protein capable of affecting a variety of cellular processes important for tissue regeneration. Or growth factors are small glycoprotein. These proteins are produced by all animal cells whose job is to communicate with other cells. Growth factors are important in both normal physiological process, for example, wound healing, nerve generation, and abnormal, and in case of abnormal processes, for example, cancer and diabetic retinopathy. These are the six main growth factors. Number one is the PDF, PDGF, that is platelet-derived growth factor, FGF, fibroblast growth factors, epidermal growth factor, EGF, transforming growth factor, TGF, Vascular endothelial growth factor, VEGF, denoted as VEGF, vascular endothelial growth factor. In the final, other cytokines have chemical like interleukin 1 and tumor necrotic factor, TNF, tumor necrotic factor. So these are the six growth factors which take parts in this. The common growth factor, the platelets, derived growth factor, PDGF, activate the fibroblasts, smooth muscle cells, and monocytes for the proliferation and migration, promotes mitosis of the glycides. The platelet growth factors store in the platelet granule and release on platelet activations. It is produced by a variety of cells, including the activated macrophages, endothelial cells, smooth muscle cells, and many tumor cells. They have a promising result for the speedier return to play following muscle and particularly tendon injury. Second one is the fibroblast growth factor, FGF. The company is a growth factor containing more than 20 members, of which acidic are the fibroblast growth factors, which are denoted as A, FGF, and FGF1. The basic FGF are the basic one are the BGF, FGF, and the FGF2 are the best characterized. FGF contribute to healing, wound responses, hemopoietic, and angiogenesis development. It is mitogenic for most major common cells and induces endothelial cells to release protolactic enzyme. Third one is the epidermal growth factor or EGF, can be used for patients with the recalcitrant skin, mold, and skin aging. It is effective and with specific mitogenic factor of the skin. They are mitogenic for fibroblasts, epithelial cells, glial cells, and the smooth muscle cells. Now the transforming growth factor, which is known as denoted as TGF. They are of two types: type alpha TGF and type beta TGF. Type 1 is a type alpha TGF, usually mitogenic and fibroblast, and share homology with the EGF, epidermal growth factors. Whereas the beta TGF have bifunctional effects on the cell growth and can highly stimulate growth of the same cells depending on the condition. The vascular endothelial growth factors is the fifth growth factors. It plays a central role in the growth of new blood vessels, known as angiogenesis, and it is major regulator of physiological and pathological angiogenesis. Various vascular endothelial growth factor VEGF inhibitors have been approved by the FDA for the treatment of advanced cancer and neovascular age-related macular degeneration. Then last one is the cytopil light interleukin 1 and tumor necrotic factor TNF. It induces fibroblast proliferation and collagen synthesis. Tumor necrotic can also stimulate HGH. The extracellular matrix I already mentioned in the beginning of the lecture that it is a ECM. ECM is a collection of extracellular molecules secreted by the cells that provide structural and the biochemical supports to the surrounding cells. This ECM is a non-cellular component present within all the tissues and organs and provides not only essential physical scaffolding for the cellular constituent, but also initiate crucial biochemical and biomechanical tools that are required for tissue morphogenesis, differentiation, and most. Hydrogen factor introduce fibroblast proliferation and collagen. ECM consists of three components. One is the collagen, other one is adhesive glycoprotein, and the third one is the proteoglycan. Collagens are fibrous structural protein which confers tensile strength and recoil. They give strength, okay? And adhesive glycoprotein, they are the fibronectin, integrins, laminins, and it connects the matrix elements to one another and to cells. Where proteoglycans are the water hydrated gel which permits the lubrications. Type of collagens and their location. Type 1, 2, 3, 4, and 5. The one is present in the bone, skin, cornea, blood vessels, tendon. Type 2, cartilaginous tissue. Type 3, skin, skin, ligaments, and blood vessels. Type 4, the basement membrane, various tissues. And type 5 are the blood vessels, synovium, corneal stroma, tendon, lungs, bone, cartilage, and skeletal muscle. The function of the ECMR target to the soft tissue, remain the strengthen, give strengthening, and stability to soft tissue, rigidity to the bone, supply the substance for the cell division, regulate growth, movement, and differentiation of the cells linked with it. The cascades of tissue healing is into these four level phases. Most is inflammatory, proliferative, and maturation. Here are the four phases. And thank you very much. This is all about the tissue.